everyone. It's time to begin, I think. Can everyone hear me this time? I don't think I'm muted like I always do, so that's shocking. Okay. I bet I put the stream settings on normal latency. I did. That was a giant mistake. So, 1/2, 50%. Yes, I will only make 50% of mistakes every day. I wish I could change that, but unfortunately it doesn't let you change the stream settings once you screw it up. Okay. So, let's begin. Right. So, homework 3 this week. I guess let's put it up on a live board maybe or something. I'll open one. Okay. Almost there. Guess I'll just add a page. Okay. So what's new? So colon question mark. Homework 3 is out. Due Friday. And then remember, Lab 3 will be given out during your discussion. And so that's due Friday. So for Lab 1, we had something like 454 out of about 570 people submit something. So that's why I'm doing the Lab 1 redo. And currently, I think I've seen at least 17 submissions to that. I didn't do the survey yet. I guess we could write it up. I was kind of taking the weekend off, to be honest. Not doing a whole lot with regard to this class or anything. Are you allowed to use in statements inside of if statements? Good question. So, the good news is that Lab 2 had about 500 people out of the 570, which is, you might think, well, that's still not so great. What happened to those 70 people? And I still think that same thing. I definitely want those 70 people to also submit at least something. But Lab 2 had a higher rate of submission than Lab 1. Hopefully Lab 3 will be 570 out of 570. That's what I desperately want. I want that. But we'll see what I get. Okay. I've released a calendar for the schedule of the semester. So that's up on the announcements. So a calendar is out. You notice at the end of the semester we have like 3 or 4 special topics days. I might do some Flask, maybe Tkinter, stuff like that. So this is like a GUI package. This is like web development. Yeah, I don't want it to go so low though. But the point is that that's way in the future. First things first, we have to get through all the homeworks and all the projects and the rest of the semester and all the exams. And then we get to do some special topics days. And then whatever else, right? So, okay. Let us proceed to the actual class then. I think that's it for announcements. I don't really have anything else other than do your homework, do your lab, get it all in, and then I'll be happy. Okay, so last time we talked about for loops and lists. So we declared lists, and we learned a few things about lists. Let's see, what did we learn about lists? I guess I should actually increase the font size. Let's do that. And so we learned how to declare lists. So you declare a list by saying something like square brackets, and you can say A, B, C, D, E, F, and so this is some letters. And if you want to iterate through that list, so this is basically like review a little bit. You can say for letter in some letters, and then we can print out the letter. So what actually happens here, remember what this does is it creates a letter variable and then repeatedly takes elements out of the list and assigns them into the variable letter, which then can be used in the loop code. So you can always say something like, the letter is let us run it and see what happens. There we go. You see the letter is A, B, C, D, E, F. So you see how it goes through the list and it outputs everything. So today I want to cover the following things at least. I want to talk about split strip for strings, and I want to talk about range, and technically I want to talk about for each versus for I loops. Now in Python, everything is really a for each loop, but we have kind of invented the idea of a for I loop in Python, and I will show you what that means, and it uses the range object. So for instance, let's say that you want to add up all the numbers between, like, I don't know, 1 and 10. So we say for I in range 10, and so I'm going to print, well, let's make a variable called total. What happens if you put a for loop in another for loop? I'll show you that in just a second. So if we're going to add up all the numbers between 1 and 10, then I'm going to say for I in range 10. Now, of course, this actually is wrong. Technically, this is wrong, but I'll show you what it does in just a second, and then we'll fix it. So right here, what it's going to do is we're going to print out all this stuff, and so we get 45. Now, we know that if you add up all the numbers between 1 and 10, you actually get 55. And the reason that this doesn't work as you might think is because it starts at 0, right? This range object always starts off at 0, unless, of course, you put it in a different start, which I'll show you how to do in a minute. And it always goes up to not 10, but it goes up to the number -1. And so there's a reason why it does that. And so if you think about it, like, why does it go from 0 up to 10 minus 1 instead of 1 up to 10, for instance? And so the reason that you can kind of think about here is that, well, like, what does a list, when you have a list, what are the indices like? And so you'll be like, oh, right, they start at 0, and they go up to the length of the list minus 1. So that's why range does that. Range is built to function with lists. So that's kind of the idea, is that range is built to, it's kind of built to correspond with the indices that lists have. And so, as you can see, that's why they're designed to work that way. Okay, cool. I'm just loading the slides for today, just in case I want to use any of it. Yeah, and so, okay, so basically if you wanted to add up all the numbers between 1 and 10, you would say, like, input, what number do you want to add up to, and you would have total, or no, I just call it n is equal to int. Okay, I will eventually type something correctly. And then here you can do n plus 1. And so this will go from 0 up to n plus 1, and you know that 0 is okay because 0 plus anything is equal to that anything. So you don't need to worry about it. Okay, so basically that's how range works. So we generally call anything with a range object in it, we'll call these for I loops. And anything without range is basically for each. So this is a for each loop. But the real distinction is not that the thing has range or not. The real distinction is that a for I loop, the loop variable, is either an index or integer or some kind of count, right? Whereas in a for each loop, each letter is actually the variable, the loop variable. So we're not accessing things at that position. We're just saying for letter in some letters, and that gives us this this formalism, right? Because we just get the letter A, B, C, D, E, F. We don't get their positions. So okay, so that's the two different types of loops, and you'll have to kind of get used to it. We generally try to distinguish them, and the reason why we do is because it kind of helps people conceptually think. Like if I ask you, should this thing in your project be a for I loop or a for each loop, the question is not some vague thing. It's, do I want an index to the array or an index to the list, or do I want the actual thing in the list and not care about where it is? And so that's the question. It's like, do I care about the index more, or do I care about the element more? And so, index means for I, element equals for each. Now, remember that, for instance, if I have a list is equal to, say, 1, 2, 3, 4, 5, are there while loops in Python? Yes, there are. Yeah, while is a keyword, right? So there we go. I haven't taught anything about while loops yet, and I'll teach about them next time, but I haven't said anything about while loops. The reason, okay, so cool. So let's say for I in L, I plus equals 1. So remember what this does. This says that I is equal to I plus 1. And so now we're going to print out L again, right? And so what you're going to see here is that here, this list is unchanged, right? Even though we added 1 to each of the I values. And the reason why is that this is actually a for each loop. And why is it a for each loop? It's a for each loop because I is equal to elements in the list L, right? They're not indices. So, for instance, I could have made this anything I wanted to. I could have been like 7, 8, 3, 12, 1, right? And so these are clearly not indices anymore in any sense. So, and the list isn't changed here. So the next question you should ask is, well, okay, how do I change a list element, right, in a for loop? Let's say I want to add one to every element in the list. So what can I do? So here's how you can kind of do it. So what you want to do is you want to say, for, let's just say index in range len L. And so let me explain what this is doing. So index is actually an index in this case. It's correctly named. And so range is giving us 0 up to a number, right? So range gives us 0 up to a number, and then the length of L gives us that number, right? That's the length of a list. And so len is a keyword in Python that you can use to determine the length of a list. It's basically like in C++, if you have a vector, it'd be like L.size, or I think in Java it might be like L.length or whatever, depending on the kind of data structure you're using, if it's a vector or an array or whatever. So, but this is the construction in Python that you have to use. So what you do is you create a range, and you go up to the length of the list L, like this. Okay. So now, if I want to add something to each element, what I can do is L at the index plus equals 1. And so let me show you how this is different, right? So here, remember that this is I is a copy of the elements in L, so it doesn't change the list. But here, we're actually accessing the element at L at index. So this will change the list. So if I print out the list now, if I print out L after this loop, what you're going to see is that it's going to have changed the value, and I guess it's going to have added 1. So here, let's just say 7. And so you see here, it says 7, 8, 3, 12, 1, right? That's after it printed the list here. And then here, it actually adds 1 to every element in the list, because it accesses the list at the index, and then it adds 1. And so this actually changes the value, right? Actually changes the value of the list. Okay. So, yeah, and in general, if you ever need to test if a list of a certain length, you can always just print out, for instance, the length of L, and that will give you an integer. So, it's a completely legal keyword in Python. You can just print out the length of the list. All right. So lists are mutable, so yes, you can change them. Yes. Can you start loops off from a higher number and not 0? Yes, you can. Does it matter what you call index? So no, it doesn't matter what you call index. So I could call index element here, right? And you might say, well, okay, but that's the only reason why I call it index is because it is an index. You're allowed to use single letter variables for indices in loops, as long as it's clear what you're doing. Can the user set the number of items in a list? Sort of. I mean, so if you say like num equals int input, how many elements, you can always say like the list is equal to an empty list, and then you can say for num, or for I in range num, the list dot append would be 0, right? And then you can print out the list. So if you do something like this, you can let's add up to 7, and then how many elements? Let's say 12 elements, and then you see here, if you counted up all this stuff, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, of course, appending 0 is kind of pointless, but you can see that you can replace this line with something better, right? That does more, right? This line is kind of just a dummy line. But it does at least add something to a list, right? So you can create a list of any size using that. So, okay. Yeah, so does it matter what variable you call index? No, it doesn't. I'll say that again just because I think it's valuable to say. And then back to that question, can you do anything else with range? So, am I going to go over merging a list? That's a homework problem. So, not really. Not really. Unless you have a specific question about it, right? So, okay, so here's the thing. Let's talk about what else can you do with range, okay? So, for instance, let's say that we want to count from 2 to 10, just using range. So we can say this: for I in range 2 to 11. Remember, you have to go. It's really 10 plus 1. Well, I mean, don't Google it. I mean, try to solve it yourself. Okay. So basically, if we want to print out all the numbers between like 2 and 10, this is how to do it. Numbering a list. Do you mean like how lists are indexed, for instance, or? So you see here that this last thing, right? This starts at 2 because we put in this argument. So range has some secret arguments that are usually suppressed. They're called default parameters. So normally, if you just put in, you actually see here in the autocomplete, if you don't do anything, it just knows where to stop. So this is where to stop, right? But if you put in 2 elements, if you say range of, say, start and stop, then this tells you, say, start is equal to 3, right? Let's make this equal to 17. So this will go from, well, actually, let's just print it out. There we go. And so let's see what happens. Oh, no, wait, this will print something weird, but let's do it anyway. I think this is going to print, like, range object at memory location, blah, blah, blah. But whatever, 3, how many elements? 80. Okay, what do we get? Oh, no, we actually just, it was okay. Yeah, I'll handle that question. I see it. So, okay. You see how here it just prints out range from 3 to 17. Basically, my hint for number 5, or part 5, is that you want to basically instead of using all those if statements, you just want to do the same thing, like basically the trick in part 5 on homework 2 was mod, and so the trick on homework 5 and homework 3 and part 5 is mod. But here you're going to use mod to access a list, right? So I'll talk about that in just a second. I'd like to get through range a little bit. So here, here are the 2 arguments that you can put into range. You can have start and stop. Now, if I attach a list to this, then you actually see all of the different elements here. So you see here that if you just have the range of stop and you put a list in front of it, then it converts this range into a list. And so you see that here it goes 0, 1, 2, 3 all the way up to 16. And that's what this is doing here. And then here, if you do a list with a range starting at 3 going up to 17, it starts at 3 and goes up to 16 because that's 17 minus 1, and that's the list here. Okay, so there's one last parameter, right? So there's a start and stop parameter. There's one last thing you can do. Yeah, I mean, so if name equals main is a little bit less of a, public static void main, but anyway, we'll talk about if name equals main just as soon as I want to get through range. So, okay. So here, let us do something like this. What if we wanted to count from, let's say I in range, say 3 to 80, but we want to step up in size by 5. And in order so that it doesn't print forever, I'm going to do end equals space. So you can use end equals space. So what end is equal to space does is that it's going to ignore, instead of doing a new line, it's just going to do a space at the end of the print statement. Okay. So, all right, let's run this and see what happens. 7, 7. Okay, so here's what happens. So here it starts at 3, and then it goes up to 8 because that's 5 more. Then it goes up to 13, 18, 23, 28, 33, all the way up to 78, right? And so when it hits 78, does it go on to 80? Well, it goes up to 83, but 83 is bigger than or equal to 80, so it won't take it. So for instance here, if I do something like for I in range, here, you see that here what it does, oh, I'm sorry, I should put a print statement in between so that it's clear. This will print an end line. Let's do 7, 7, okay. So here it starts at 5, right? And it steps up by 10, 15, 20, blah, 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 all the way 65, 70, 75, and you're thinking, should 80 pop up? Remember, right? Does it ever actually hit this number? No, it's not allowed to actually touch this number. So when it gets up to 75, it adds 5, it gets 80, and it breaks out. It doesn't do the 80 step. So the way we usually say this is that range takes a start element, a stop element, and a step element. And by default, start is equal to 0, step is equal to 1, right? You always add 1 by default, and the start is always 0 by default. So you can always do any of these 3 things for range. You can either do stop, right? That's the only argument. That's the first one that's not default. Or you can do start and stop, which is the second argument, right? So if you put anything in here, it becomes start. And then if you put 3 arguments in, then it's start, stop, and step. Is there any way to increment by a float? So no. The things in range must be integers. The only way to increment by a float would probably be like, so if you wanted to increment by like tenths or something, you could say like for I in range 10, or maybe for I in range 11, and then you would say like f is equal to I divided by 10, and you could print out f, right? So you could do something like that. And that would give you something that increments from 0.0 up to 1.0. And that will do that, but you see that here I'm not actually incrementing in terms of floats. These are actually integers, and I'm just dividing by some kind of total. Okay, so that's what I wanted to say about range. Let's see here. What do I want to say about... Yep. Okay, cool. Yeah, I guess I'll talk about in after... So I'll talk about if name equals main now. So this is basically an aside. from lists, for loops, etc. So let's talk about if name equals main. So here's the thing about it. You probably won't understand like 100% of what I'm saying here, but then it doesn't matter. So normally in most programming languages, I should say, unlike Python and like Ruby and stuff, but in like assembly language, Java, C++, C#, whatever, right? There's always something called like an entry point, right? So you always want an entry point, and that's where does the program start? So for instance, let's see. I don't have Visual Studio open. Let me open Visual Studio. Here we go. I think this is it. Is this it? While that opens, I'll just say that like in Java, usually you'll have some like class, my class, and inside of it, you're gonna have like a public static void main with maybe some string array for arg, args, right? And so this is like the standard entry point in Java. So what Java does is it looks around for this specific function here that has a name of main, and if it's a public static void, then basically what happens is that Java says, aha, this is if you run this class, this is the thing that it wants to execute, right? So it's looking for this function. And in C++, for instance, it looks for basically just something called int main, right? And so int main will like return 0 and whatever. So this is C++. Okay. So this is like Java, this is like C++. So now let's get to Python. In Python, there is something called name. And now you're like, well, that's pretty obvious, because if name equals main, then there should be something called name. But you might also notice we never declared name, right? And we don't usually, right? Don't mess with name. You can redefine name and screw up everything, but don't do it usually, right? Like that's like a 99.9% don't do that. The reason why is that Python keeps track of this variable name for you. So let me show you what this does. And so let's add it to 7. Okay. And so here you see that when we printed out name, it's literally just a string, right? It's a string underscore underscore main underscore underscore. And you're thinking, okay, what? So who cares, right? And the answer is, for now and for most of this class, we don't really. But if you ever write a program with more than one file, right? So let's make a second file. And so let's do this. And so let's print out name here, right? So if I run the second file, all it's going to do is print out main, right? So here, when I ran the second file, and you see how it's printing, this is actually running the second file, it is printing main, right? So you're like, okay, that makes sense. But what if I do this? Let's see. I think I might have to rename it because I don't think it likes these hyphens. Let's rename it. Where is rename? It's somewhere in here. Okay, whatever. I guess I can always just do it manually. Whoops. There we go. Perfect. So it says it's unused, but I don't care. So here it's going to print out, well, let's just see what happens when we run lecture 6 again. And now we're not running the second file that only has like one thing in it. We're running the main lecture 6 thing. So let's do that. So what number do you want to add up to? 7. How many elements? 7. And so what you see here is that the first file we run is called lecture 6 for loops and lists2.py. But it doesn't, but Python thinks its name is main. On the other hand, when we imported the second file, right, this second file here, literally it just has a print statement that has name in it. And it knows now, like if you print it out, it says, oh, hey, my name is L6 second file, right? So it knows its name is not main, and it knows its name is whatever the file name is. So generally, an if name equals main if statement, what it's going to do is it ensures that this code, and only this code, is run, or not only this code, it ensures that this code is run whenever this is the main file you're running. And so basically, if you put an if name equals main here, then what's going to happen is, when we import the second file, let's print out something else. Print file imported, print main code run. And so what you're going to see is that when we run the code, it's going to say we want 7. How many elements? 7. And so it says file imported here, right? File imported here, but it also says I am the main file, right? So it does not say main code run. So it doesn't say this. So this if statement prevented this code from running here. So why do we, like, what's the point of all this? And so the point of all this is that sometimes you want to put some kind of like testing script, other kind of code that only runs whenever you run that specific file. And so you can always kind of hide that code in the if name equals main block. And if you do, then it won't run that code unless someone runs that file. So in general, that's the whole purpose of it. And I mean, so for homework 3 and beyond, you should use if name equals main. And the question is always, where do you put if name equals main? You put if name equals main as like right under your comment, like header comment, basically. All code should be indented and inside the if name equals main block. Do we put constant variables and comments in the if statement? Comments don't matter, so it doesn't matter if you put comments in there or not. They can be outside. Global variables should probably be outside, just for future learning purposes. It's always good to keep your global variables outside of. So because especially here, like if you do something like blah var equals this is a blah var, right? And if I put it outside here and I import this, and then I say L6 second file dot blah var, so it'll print here. So it'll print here, but then if I stick this thing into the if name equals main block, then it'll give us it should give us a name error, right? Attribute error. Okay, so attribute error is like name error. So it depends, right? If you don't want the variable to exist, then you stick it inside. If you do want the variable to always exist when somebody imports the file, then you have to stick it outside. Okay? So we put our entire code in name equals main. The answer is yeah, basically. For now, especially before you do functions, so all of your non-function code should go in the if name equals main block. So your functions should go outside of it, but we haven't got to functions yet. So yeah. Okay. All right. So, and why do we start this so early? The answer is I don't know. Like this is just we're just trying to get you into good practice here. So there's not a like firm 100% useful reason to start doing if name equals main right now, right? Like none of your code is so complicated. All non-function code, including variables. So again, it depends on importing, but I'm going to say for you guys, it really doesn't matter. All your variables can be inside the if name equals main block. If you leave a variable outside the if name equals main block, that's fine, I guess, but like, you know, things should be inside the if name equals main. So you see, basically, Python is a language that when you like include a file, when you import a file, it actually just runs that file. And so that's why you have these if name equals main statements, is to be like, if this file is ever imported by a different file, the point is that you don't want to run some of the code in there. And so this will prevent any of the code that you don't want, you know, it'll declare variables and it'll run code that you do want to run, and then it'll stop the running of any code that you don't want to run. So that's essentially the point. But yeah, it's basically it's all for the future. Nothing useful right now. Okay, so that's all I really want to say about if name equals main. It's one of those things that you kind of eventually have to learn in Python, but it's also, you know, kind of not, it's not very important until you learn functions, classes, once you start importing other files. So the only real time when it really gets important is when you're importing other files, and that'll actually matter. Okay, so let's get back to lists and loops. So what more do I want to say about lists? I'm going to pull up my slides, because I think I had something. Right. That's what I wanted to say about. I wanted to talk about in. Yeah, I would say like less security and more like code prevention. Basically, you don't. It's for when you as the programmer don't want some like test code to run that's in some other file. You stick that in the if name equals main block. I don't think it really makes things more secure, but I don't really know what security means anyway. So, okay. So, let's say, is milk in the fridge? So, you know, that's a decent question. So, fridge equals eggs, cheese, lunch meat, green peppers, milk, and avocados. Though, generally, I don't know, do you put your avocados in the fridge all the time? We're kind of 50-50 on that. So, for thing in fridge, if thing equals milk, print, we have milk, right? So this piece of code here is going to, you know, basically go through the fridge, and it's going to test and see if we have milk, and if we do, it'll print it. Okay, there we go. So we have milk, right? But there's an easier way to do this. What you can do is basically you can just say if milk in fridge, print we really milk, right? And so let's do this. Let's run this again. And so it prints we have milk, and then it prints we really have milk, right? So in is a special keyword in Python. What you have to understand, so in does test to see if the element A is in the object like B, right? So that will work. And generally for our class, it really doesn't matter, but you always have to remember that like this in keyword is really running a secret for loop, right? In runs a secret for loop, okay? And so, well, it's not exactly index of, and we don't technically teach index in this class, though. I mean, yeah, So let me tell you a story. The story goes like this. I came here about a year ago to UMBC, and there is like a huge banned list, things that you can't use in 201 in Python. And of course, everybody all the time wants to basically use everything because Python, unlike C++ and unlike Java, well, Java is a little bit more than C++ because it has a lot of libraries that you can import that are kind of automatic. But, in a language like C++, you're basically given nothing. In a language like Java, you're given some stuff, and now you're given a lot more than you used to be. And in Python, basically, like any feature that you want is there for you, right? So the point about that is that, like, the reason why we kind of restrict what you can use is because there are so many features in Python that if we don't put any restrictions on it, like, the problems will often become really, 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 really easy. Because you can always just like go on Stack Exchange and find out like, oh, there's this special keyword or there's this special list function that basically does all my work for me. And so we're trying not, so the thing is, we're teaching Python, right? Here. But not really. What we're actually teaching is problem solving. Yes. And so when you think to yourself, like, why can't I use the full power of Python in this class? The reason why is because we want you to be able to take your knowledge here and port it over to any programming language that you can see usually. C++, Java, Python, C#, even assembly language, Ruby, JavaScript, whatever. And not all of the languages have all the nice features, and so we want you to understand, like, oh, in this language there's a nice feature, I can do this thing. In this other language there's not a nice feature, so I have to actually code it out. And so when you actually have to code it out, that's what we're making you do here, because it's your first time, theoretically it's your first time doing this stuff. So that's why when we say don't use index, don't use max, don't use min, don't use sum, we're not saying, like, don't ever learn these things, or these things are bad. We're saying these things are great. Python has a ton of features. I want you to use every single feature in Python the day that this class ends. But at the end of this class, my goal is not just that you become expert Python programmers. You will not really be expert Python programmers at the end of this class. You will be, like, learning Python programmers, right? You'll be like halfway there. And if you want to learn more Python, there's more Python to learn. But my hope is that at the end of this class, you'll be good enough problem solvers that you can look at any programming language and kind of work your way up in that language, right? So that's why we have all this band stuff. It is annoying, and especially for people who are used to programming, or anyone who's done a lot of Python before. I admit it's annoying, but that's the reason behind it. We're not trying to like limit what you know. If you look this stuff up on your own and you figure out that there's a lot better solutions to these problems, there usually are, but we want to make sure that you can solve these problems in any programming language if that programming language doesn't have like a MapReduce built in like Python does, or it doesn't have dynamically allocated memory or dynamic arrays like C++. You know, if you arrays are static and vectors are dynamic, and you even have to include them, right? You don't get them for free. So anyway, I mean that's all of these little aphorisms are basically right, and I know that I'm taking up class time to say this, but I get a lot of this stuff on the Discord and through email where people are like, well, I don't like that I can't use whatever feature that is, right? And I hear you, right? I'm not arguing that you should never use these features. I'm not saying that these features are bad. I'm saying I use them all the time in my code. After you take this class, you should be able to scale yourself up from where you are to everything else. So that's my hope. Okay, but in you're allowed to use. In is a good keyword. Even though a lot of programming languages don't really have it, it's definitely something that will save a lot of time. Yeah, so dot contains is the in, right? And then index of would just be like fridge.index, right? And you see that here, it's a function, right? You could do print fridge, but I'm going to not do that because we don't usually teach index. I'll think if index fixes or breaks anything. Anyway, okay. So we can also do if lemon not in fridge, print something, 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 right? So this not in, technically you could also do if not lemon in fridge like this, and this would also work. But Python allows you to kind of do the more Englishy thing here, which is good and bad, right? It's always good that Python allows you to do the not in kind of thing, but it also, you know. So if lemon is not in fridge, then print something, something, something. And if you see here, we did not have a lemon in the fridge. So, okay. So basically that's the in keyword. I don't really know, like, what else should I say about the in keyword? So let's go back to lists for just a second and talk about append and remove again. So for instance here, let's say that we have a list, and this is in the slides too, but I'll just code it in. So it's really, I think here's a problem with remove. So let me just show you what happens if this code is run. I think you'll see why it's a problem in just a second. So remove list, oh wait, let us declare remove list. Okay, so let's watch what happens here. 7, 7. And so here, what we see is that if x is equal to 5, we remove the element from the list, right? And then we print out the elements. And so basically, using your milk in list option, how would you check if milk is in the list without actually using an if statement? So milk in fridge returns a Boolean. So you need the if statement to check that Boolean for true or false, right? Now you could use that in some other kind of statement, but yeah, you could. I mean, technically, you could just print like milk in fridge, right? And if you print milk in fridge, it should print, I hope, true and not like 1 or something. But we'll see what it does. Yeah, right here. It prints true. So there we go. But let's look at this example here. So we have this remove list, which is just a list. And then here we go for x in the remove list. If x is equal to 5, remove the element and then print it. So what's going on here, right? So what's going on here is like the first time it goes through the list, it sees 1, right? So in fact, let's just debug it. Okay, 7, 7. Okay, cool. Now here we are. Where's remove list? Where is remove list? Here it is. So basically, what's going to happen? So let's step through. Here we go. So if x is equal to 5, it's not. So it's going to jump over and it's going to print. Okay, so that just printed 1. Now, of course, you can't see it because we have to flip over to the console. Where's the console? Here's the console. So it just printed 1. And then if x is equal to 5, x is equal to 4, so it's not. We're going to print it. So here it is. 1 and 4 get printed. And so now we're going to come up to our first 5. So we see x equal to 5. So we remove 5. And of course here it's going to print 5, right? And then you think, aha, I know what's going to happen. It's going to go to 6 next, right? But what actually happens is something a little weirder. What actually happens is when it removes 5, 6 goes into the 5 position, 7 goes into the 6, etc., right? They all shift back by 1. So that's something that you have to keep in mind, because when Python uses the next operator to get the next element in the list, it remembers the index of where it was looking, and it says, I was looking at index 2, which used to have a 5, but now we've removed index 5, the element 5 from index 2, and now 6 is there. So if you notice, it's never going to see the 6, because 6 gets shifted back into the 5 position, and then it gets skipped. So let me show you that happening. So here, x is equal to 5 again. You're like, how did it get 5, right? Oh, I'm sorry, no, x equal to 7, right? And you're like, how did it get 7? And it got 7 because, remember that 6 shifted into the 5 position, so now the next operator gives us the next thing in the list, and it doesn't realize that things have been removed. So it goes up to 7 now, and that's what it does. And so remove will skip elements. If you remove an element before it, it remembers the index where it was, and it advances to the next index. So if everything shifts back, it's not going to know that. And so it's just going to give us 7 now, and then of course it's going to print 7. Cool. And then here we get 5, right? And then it removes 5. And then you might think, well, there's still an element left in the list. Like, what about this 3 element? Maybe it'll find that element. But then here it says, what's the next element? But remember, once it removed that 5, the 3 shifted back into the 5 position. So what ends up happening is that the for loop gets the stop iteration sign from the list. The list actually gives it a message that says stop iterating. And so what we're going to have now is it's actually just going to, you see, variables are not available, frames are not available. What that means is that it's just jumped out of the code. We're done, right? And if you look at the console here, what it printed was 1, 4, 5, but it removed the 5. The 6 went into the 5 position. It printed the 7, removed the 5. It didn't print the 3, and then it exited. So let's print remove list at the end of this, and let's just watch what happens now if we just run this code. So you see here that what happens when you run this code is that the list is what you expect, right? The list is 1, 4, 6, 7, 3. But the things that you printed out were 1, 4, 5, 7, right? It's like, very strange. And actually, we could even bug this thing where you might think that this removes all of the elements with the name 5 in it. But I think we can actually keep a 5 in the list if we do this. Yeah, you see, this actually causes a 5 to stay in the list, because remember, this 5 shifts back into where the 6 was. And so it doesn't get seen, so it doesn't get removed. So basically my point here is like, and so you're asking like, what's the point of this? And my warning to you is be careful mixing remove with list iteration. Because as you remove elements, it will jump over those elements. And so that's not really always what you want. Okay? So, well, how would you fix this? I think what I would do probably is, and I know that I haven't taught while loops yet, but I would just use a while loop. I'd say while 5 in remove list. So if I make remove list the original list again, and then I would do remove list dot remove 5. And so, oh, and well, before I do that, I should print out remove list at the end. Maybe I'll print it out at the beginning too, just so that you know I haven't done anything squiffy. Yeah, you can subtract 1 from the index, but actually, like, I just want this to be a cautionary note. Like, don't get trapped by something like this. But yeah, so in general, you're going to want to use a while loop for this kind of thing. Let me just show you how this would work. And you see here, this happily just, it says, is 5 in the list? Yes, remove it. Is 5 in the list? Yes, remove it. And so you know that this piece of code is going to work because what this piece of code does is it checks if 5 is in the list. If 5 is in the list in the next run, then it will scan the list again and remove the first 5 it finds. And so basically remember what remove does. Remove does not remove all elements. Remove just removes the first one. What if you used remove list like that? So are we allowed to use while loops on the homework? So for now, no while loops yet. Everything in the homework in homework 3 is for loops. Homework 4 is homework 4 is while. Okay. I mean, you technically learned it right here, but let's just pretend like you didn't. Okay. So, all right. I don't want to do 2D lists yet. What I want to do right now is, interesting. Are you a person we have to block? Don't know yet. We'll see if you post anything good. Yeah, don't worry. We'll do a whole, like, this is, you know, if you think, wow, I really don't understand what while loops are doing, that's fine. We're going to have an entire lecture on while loops. This is not all you're going to see of while loops, right? Right now, we're just doing for loops and lists. You know, that's just the nature of the universe. So, okay. Homework 3, do you want to put if name equals main? Yeah. So, okay. Alright. I really don't know what you're doing. I feel nervous about it, so I am just going to block you. Okay, I don't know if you were a legit person or not, but yeah, goodbye. Okay. So, okay. What the last thing that I want to do today? So the last topic for today, I want to do nesting of loops. So for instance, so let me just do my first example here. There was just some person who was posting like random numbers, and I'm not sure if they were a human being or if they were some kind of troll or some kind of robot. Really, it doesn't even matter because they're gone. If they were a student, they can come and complain to me. I'd be like, I really just had a question. I didn't mean to do it. Okay, so let's look at what happened here. So, Actually, even better than this, let's just print out. There we go. Here we are. Okay, so let's see what's going on. And let's make it a little bit simpler. Let's make it smaller, because there's nothing special about the number here. So, okay, ignore everything above here. Let's just pay attention to this block here. So, notice here what's happening. So actually, let's even just debug it. This is even better. So when I is 0, right, so I gets printed first. So basically what happens is I is 0, j is 0. And then we go into this for loop here. J go from 0 to 1 to 2 to 3 to 4, right? And then this for loop ends. And then we get this print statement, which is just going to give us, this gives us the empty line. And then what we're going to do here is then we're going to go back through. So now, I is equal to 1, and then j is equal to 0, 1, 2, 3, 4, right? And so this is when I is equal to 1, j scans through 0 to 4, and then at the end of this, we print an empty line just to, carriage return us to the next line. And then we do it again. Now I is equal to 2. And we do the same thing. So it goes 2, and then j cycles. And then we do 3 and j cycles, and 4 and j cycles. And remember, range 5 goes up to 4, so that's why that happens. Okay, let's debug it and watch it actually working. Here we go. Debug. I always just pick 7. Here we go. So now, let's do it. Let me delete this comment so that it's less confusing. Okay, so now j is equal to 0, and then it'll print. Now j is equal to 1, 2, 3, and 4. And now, where's it going to go? It's going to print there, and then when it bounces back to the I loop, hopefully it'll update and show us that I is equal to 1 now. It didn't show us I equals 0, so that's very sad, but hopefully it'll show us I equals 1. Oh, it doesn't. Let's see if I move the breakpoint up to here. Let's re-debug and see if it, okay. Oh, it doesn't want to do it. I don't know. It's sad. I wanted it to show I here, and it should usually. I don't know why it's objecting. See here, it's cycling through the J's, and then here we go. And then the next thing it'll do, and actually you can see the variables here. Here's I and here's j, and then what you'll see is when I click this button again, it should advance I equals 1. It might take 1 or 2 clicks to advance to 1, so let's see. Yeah, it goes up to this line, and for some reason it doesn't advance it when it hits that line, it advances it right after. So when we click this next one, you'll see I just advanced to 1, and j is now still 4 because we haven't entered this loop yet. And then, there we go, j goes back to 0, 1, 2, 3, 4, and then here, if you notice, hopefully when I click this again, it should advance I to 2. And it did. Yay. Okay, so then j goes from 0, 1, 2, 3, 4, and if we look at the console right now, you see that this is what's happening. And so as we go through, now it'll print the next line, and then here it'll print out 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. Then it'll print out the next line, 4, 1, 4, 0, because arrays start at, I don't know where, crazy, 4, 2, 4, 3, and 4, 4. So, basically, if you ever need to do something where you need multiple for loops, and you can do both for I and for each loops. So, for instance, here's an example of something you can do. So, let's say first names equals Adam, Ben, Charlie, Dave, and last names equals Aronson. What's a good B name? Boron. Coventry. I don't know. And Delta. It's not even a name anymore. Who cares? But we can make for first name in first names, for last in last names. We can print out first, comma, last. And if we do this, yeah, Barry Benson, right? There we go. Maybe. Okay. All right. Let's not debug this. Let's just run it and show what happens. So if we run this thing, now I don't know why anyone would ever want to do this, for instance, but what now you've seen is that it combines every first name, right, with every last name, because first it sets it to Adam is the first name. It's funny. And then it scans through the last names and joins them together. And then here it goes Barry, and then scans through the last names, and then Charlie, and then scans through the last name, and then Dahlia, and scans through the last name. Right? So you can do this with both. So technically you would call this like a for each loop, but it can also be nested. Generally, this will happen if you have two lists or something that you need to somehow... what does format var mean? So if you have a string, right? If you have like s is equal to my string, and it has these brackets in it, you can hit .format at the end of it, and you can stick in basically something to be inserted into that string. So you can basically put in like, hello, right? And then if you print out s, then it should say my string hello. If you're wondering, do I have to use format, or can I use the C++ Java as, whatever printf looking stuff? It really doesn't matter. I don't care how you print things out. So here it'll say my string hello. So it basically like inserts the this string in there, but you can also do this with integers. So you can say 17, and it'll work. So it's pretty forgiving. It'll let you basically do whatever you want. And if you do two of them, then it'll just put them in order. There's other more advanced features that you can do with this format stuff, but I'm not really gonna talk about it until we talk about anything that even vaguely relates to those features, because there's no point in telling you all the advanced features when you don't even know like any of their possible applications. So yeah, so no, I don't think nested loops on homework 3 are required. Maybe, so there might be some nested loops on homework 4. And so you see that we're going to have a class on Wednesday. Do I prefer format to concatenation? I don't know. I really have no preference. I think can you use end? You can use end if it's useful. Sure. I mean, yeah. Basically, anything you can stick into print, I basically unbanned all things you can stick into print. So, what is end? Yeah, so as I was saying, end is basically, normally end is the next line. But if you don't want, so for here, if you notice that after it printed out these pairs ij, it didn't go on to the next line, it just printed a space. And the reason why it printed a space is because I changed the the secret end character from new line to space. And if you leave it as end line equals new line, yeah, it's like sep. which I haven't taught yet either. So basically here, this is what it would look like if we just had a regular print statement, because end is equal to the new line. But if you make end is equal to space, then it gives you the nice grid-like printout, because it'll just put a space in between them instead of hitting a new line. Print here hits a new line because its end is still set to new line, right? But you don't need to worry about that. Okay. Yep. So that's our introduction to nesting loops. So I don't know if it's a very good introduction. I think it's probably fine because you don't have to use it at least for another week. And so next time we're going to talk probably a bit about 2D lists. We'll talk about while loops. We'll talk about nested loops and all that stuff. So we'll talk about all this a bunch more. If you haven't done Lab 1, and this is just an announcement for literally anyone who watches this video at any point, if you have not done your Lab 1 and you got a 0 on it, and you don't have a legal extension, right? So then you should do the Lab 1 redo. It's going to be available until Wednesday, at which point I'm going to just write some automatic grading script, and so you will get like some kind of auto grade. So try, as I said in the email, try as best as you can to match the input. How do you add inputs to empty lists? So if you want to add something to an empty list, so if you have my list is equal to empty, you can always do mylist.append, say 5, and then I haven't really talked about append today, but I used it once, I think, but I've done other things. So yeah, append adds to the end of a list, including an empty list. Okay, do you touch on tuples? So the answer is, as soon as I talk about lists, as soon as I talk about mutability in a little bit, I might touch on tuples. So tuples are basically lists minus mutability, right? And so the reason why I put it like that is that, for instance, like a tuple, you can do 1, 2, 3, 4, 5 like this, and you can say for t in my tuple, print t, and so this will work. So that's going to work. So this thing will print out everything in this tuple, and you notice that it's parentheses and not square brackets. But this is not going to work. So this will break, and the reason why it breaks is because tuples are lists without changeability. So you cannot do my tuple at, for instance, 3 is equal to 5. And I think Python is even going to try to yell at me. It's going to say, tuples do not support item assignment, but I'm going to do, could you do that? Yes, you could. So what number do you want to add? 123, 79. Whoa, where was that error? Here it is. So remember that standard error is always a little bit faster than standard out, so you notice that the error actually occurred here, but because standard out takes a little bit longer to print sometimes, standard error happened a bit earlier. And so you notice here that this says, tuple does not support item assignment. And the reason why it's saying that is because tuples are immutable. So you cannot change them once you declare them. So that's why you can't change the item, you can't change this element. So if you want to change the element, you can always make it a list. If you don't care if it's ever changed, then it's a tuple. There's some uses for tuples in Python, but generally lists are fine. You don't really, technically you never actually need a tuple in this class, so that's why we don't teach them very strictly, but yeah, tuples are lists that can't be changed. All right. Well, I think that's it for today. I think we've done good. We've gotten through range, right, with the 3 things, start, stop, and step. We've talked about if name equals main. We've talked about using the indices in lists and using range and len together. We've talked about the in keyword and determining if something is in or not in a list. We've talked about a little trouble with remove, which is always useful because remove is a little troublesome. And then we talked, very briefly and not very interestingly, but kind of briefly about nested loops. I'll show you some more examples of nested loops next time, and we might get into 2D lists and do something more interesting with them. Like these are obviously, like, if you think like, oh, well, what's the point of this? Like, this is really stupid. It kind of is, but they're just basic examples. So, we'll get into more interesting examples next time. All right, and so I don't forget, let's commit this to the GitHub. And then finally, let us not just commit, let us git repository. Push. Actually, wait, I should send this other file up too, just in case you really wanted to. So add it, commit it. Now let's push. Hopefully will it make me log in? I don't know. Sometimes it does, sometimes it doesn't. Okay. Yeah, so if you want to get to the GitHub, I think I sent out the link, but I'll just post it here. All right, I think that's it for today, everyone. I will see you guys on Wednesday, and by see, I mean I will see my computer screen on Wednesday. So later, everyone.